My name's Sean Kelly from the Nanotechnology Industries Association, and it's very nice to welcome you all here this afternoon. We've just got a few housekeeping things to announce first. So we would ask that everyone stays on mute during the session. If you could use the chat function to ask questions. So if you hover your mouse down towards the command panel, there should be a little box that says chat. If you just go in there and ask your questions, we can make sure that the speakers answer them. Where time permits, we may be able to have some time where questioners can be asked to unmute to join the discussion, but it will depend on running to time because we do have a lot to cover this afternoon. And also just a quick note that the webinar is actually being recorded and it will be published afterwards, and you will all be sent a link when it's available. And I'll now hand over to Thomas Kulbusch, who is the coordinator of the NanoHarmony project, to give us our formal introduction. Thank you.
Thanks a lot, Sean. Dear ladies and gentlemen, it's a great pleasure for me to welcome you to the third webinar of NanoHarmony. NanoHarmony is dedicated to deliver the scientific background to needed test guideline and guidance documents for the assessment of nanomaterials. It strengthens the exchange between the transformation of science into regulation. It explores how the developments and processes can be better organized to speed up duration from first identified needs to the finalization of the test guideline. So this webinar, based on the last NanoHarmony workshop from the 3rd to the 5th of November, gives a platform to you to answer open questions from the last workshop, to ask new questions, as already was said by Sean, inform you about important progress, discuss test guideline specific questions. So with the combination of a workshop and a webinar, we aim to facilitating the international interaction on topic specific activities. So with that, please use this chance. Enjoy the webinar, and I give the word and the moderation back to Sean.
Thank you ever so much, Thomas. So just to quickly have a look at the agenda for everybody, we'll be moving pretty rapidly throughout each of the sessions to give maximum time to get through the content. So if I could ask Richard if you want to unmute, and if you just shout when you need the slides changed, and Nicolina will advance them for you. So welcome to Richard Handy from the University of Plymouth on the first topic, which is modifying the bioaccumulation testing strategy with fish for nanomaterials.
Okay, thank you very much. Good afternoon, everybody. If I go to the next slide. So, as many of you know, persistence, bioaccumulation potential and toxicity are key triggers for environmental risk assessment. And of these, bioaccumulation potential has been given perhaps the least amount of attention for nanomaterials. And our effort has been around that topic. Next slide. So how do we test for bioaccumulation? Well, the traditional test, OECD TG 305, uses a chronic exposure of fish over a 4-week period. There's a choice of test methods using either the water or the food, and we measure the accumulation rate over time, or you can calculate that kinetically from K1 and K2 to arrive at a bioconcentration factor or a BMF for the food route exposure. And so we need to wonder, how well this is working for nanomaterials. Next slide. Well, traditionally for organic chemicals, we've used the log P octanol water partition coefficient, or KOW test, to predict bioaccumulation. And here you can see nice correlations with organic chemicals. And so the KOW test has been one of our main triggers or predictors for starting bioaccumulation testing. Next slide. However, there's some problems. The KOW test isn't intended to work for nanomaterials, and it doesn't work for some of the materials. Also, the test itself assumes solute chemistry that isn't so relevant to the dynamic equilibria of nanomaterials. And we also have some practical problems. So under the current test guidelines, if the KOW test is not practical or it's not working, then you're required to move directly to the in vivo fish test, TG305. And that test uses something like 150 fish and costs something around 100,000 euros to do. So using lots of animals is expensive. You click the next part, 2 clicks. And again, thank you. And so we've got some problems. We have too many nanomaterials to test, and it's unrealistic and expensive to do TG305 with all of those materials. And with the current scheme, there isn't too much consideration of animal welfare in terms of animal alternatives in the testing strategy overall. Next slide. And so we've been thinking about this problem and detailed some of the issues and some of the potential solutions in a review paper from our previous EU project. And so if you want to get your head around some of the details of what the problems are and potential solutions, please go ahead and look at this paper in ES Nano. But next slide. But what we wanted to do with the NanoHarmony workshop was to kind of start with some clean ideas and fresh thinking. And the overall aim of the workshop session we had in November was to discuss how best to proceed with bioaccumulation testing for nanomaterials in that regulatory setting. So, for example, with OECD guidance documents. And we discussed 3 areas. Question 1 focused on alternative triggers to the TG305 KOW measurement. So what could we do instead of log KOW? We also had a discussion around invertebrate alternatives that we could use to waive TG305. And we discussed earthworms and various other organisms. And then finally, we had another discussion around alternatives to in vivo fish that looked at fish alternatives, so fish cell culture using fish tissue and so on. And this is all part of an effort to see if we could rationalize the testing strategy and screen out nanomaterials that we don't need to test on live fish. Next slide. So what were the outcomes of those discussions? Well, let's start with the issue of choosing a chemical trigger to initiate testing. We know that the log KOW is not working very well for nanomaterials, and the suggestions are that we use a particle property that's more relevant to the behavior of nanomaterials that might predict bioaccumulation. And so we had a discussion that looked at particle size, hydrodynamic diameters or aggregation state, dissolution rates as possible triggers. And we've also done some meta-analysis as part of NanoHarmony. And while these are all good suggestions for triggers, there's no single metric so far that's the best predictor. But what we are able to do is to come up with simple regression equations that can give a prediction. We also discussed attachment efficiency and the inherent properties of particles for attachment that might link to bioaccumulation, and also GD318 provides some measures of alpha for the attachment efficiency. So that was a possibility. We also discussed some other ideas about developing a new hydrophobicity test for nano, and also talked a bit about metals and predicting accumulation from properties of dissolved metals. Next slide. So we had some ideas on replacing KOW with a metric, but what about the invertebrate testing? We wanted to find ways of reducing the amount of animal testing in the overall procedure, and there were a number of discussions around different invertebrates. One suggestion was that we use the high ELA test which is this amphipod invertebrate on the screen here, as a possibility for aquatic testing. And we also discussed using earthworms, where we're able to correlate the BCFs in earthworms with the magnification factors in fish. And we also talked about invertebrates that were in sediment tests as well, with this idea of, if we're going to do a dietary fish test, we would have an organism that was in the sediment that correlate that. And if we're doing an aquatic test, then maybe we should use an aquatic invertebrate as an alternative. There was also discussions about read across between species with accumulation data, and the issue of how you normalize data came up, and we discussed normalizing to tissue lipid content or carbon content, because obviously the fat content of fish and invertebrates are rather different. And we also had some other suggestions about using marine bivalves if it was a marine assessment, for example, under the PARCOM scheme. But the general consensus was that we could use invertebrate tests to replace or inform on the need for an evo fish test. But other techniques like QSARs for nano and dynamic modeling of toxicokinetics were some way off of being useful at this stage, although we should keep those ideas available. Next slide. Well, just to show you a little bit of data, here are some of the correlations that we've done between the fish biomagnification factors in TG 305 and the BCFs from the earthworm test, and you can see that they're correlating quite well, and we're able to show that yes, we can correlate invertebrate data with fish accumulation data. So there's a good argument for using invertebrates. Next slide. What about the alternatives to using fish tissues? Some people would prefer that if we're going to replace the in vivo fish tests, we should be doing it with a fish tissue alternative. So what's available? Well, we looked at several areas. First of all, the gut lumen for the dietary exposure method. We have a digestibility assay, which is a quick and chemical method for informing on bioaccessible fractions. And this is quite an easy bioaccessibility test to do, and we could quickly screen nanomaterials to know if they're going to release a bioaccessible fraction that might then be taken up. All of these bioaccessibility assays have been developed in fish nutrition and in human health and elsewhere, and they're mainly using acid digestion. So we do need to develop these methods for herbivores as well, but nonetheless it's a very quick and easy method. We also discussed using cell lines, and of course there are the rainbow trout gonadal cells, rainbow trout liver cells, and new gut cell lines that are available for fish cell culture. And while these are good models, there was a general feeling that they were great for screening, but not necessarily predicting accumulation. So we need to think a bit more about how to use cell culture. But it was also pointed out that if you're doing a reach risk assessment, you need to demonstrate the substance does not cross biological membranes. And so you might be able to do that with a cell culture or one of these other test systems. We also discussed some of the fish alternatives we've been developing at Plymouth for nanomaterials. We have a gut sac method that is very good at reporting in vivo rates of uptake and very similar to in vivo. And there was also a discussion around using fish embryos. Could we adapt a fish embryo test for a bioaccumulation assay so that we're avoiding using adult fish? So, some good ideas about alternatives. Next slide, please. So what's the way forward? Well, we've agreed that we can develop a chemical trigger to replace the log KOW, and it's just a question now of taking the different particle metrics and seeing what the best prediction equations might be. But we'd also like to keep that simple and not have too many protocols to include for a trigger assay to start the testing scheme. We also think we can simplify the suggestions for the overall scheme, certainly by having a part that weighs TG305 on the basis of aquatic invertebrate tests or an earthworm test. We can certainly look at the digestibility assay and other alternatives to fish as a way of, screening out materials that don't need to go to an in vivo test. But it was also felt that we need to have some kind of decision tree that protects against false positives and false negatives in the scheme, so that we keep the whole scheme precautionary, and we'll certainly keep that in mind. Can we demonstrate that the scheme will work with more nanomaterials? Well, in NanoHarmony, we plan to do that with 5 or 6 materials. But we do have a problem with carbon-based nanomaterials where the measurement methods in the tissue are not there yet to allow us to do bioaccumulation kinetics. But nonetheless, we have a good bunch of chemicals that we can look at. And there's a good prospect of developing a tiered approach to testing that will reduce the burden of work and also introduce the 3 Rs and aspects of animal welfare to the testing scheme. Next slide. So I think that's all I've got to say. There's perhaps a very quick minute for a question or two.
Hi, Richard. There is already a question in the chat, which I can read out for you, which is, what about fish in larva state as an alternative? I'm aware that there are some published studies in zebrafish larvae, and seems a good model for bioaccumulation studies.
Yeah, okay, yeah, I can see the chat now, yeah.
Okay.
So good question. We found with nanomaterials that the materials accumulate mostly on the chorion of the fish embryos and not in the embryo itself. And so the chorion is very protective. And so instead of using an embryo test, I would prefer to see this as a fish larvae test. They do seem to be quite sensitive to nanomaterials. And if you pull the larvae into a tube, you can get enough to do some single particle ICP-MS on, or a total metal measurement, for example. So using fish larvae is a good suggestion, but there's quite a narrow window that we can use them in relation to the animal welfare regulations, only a couple of days after hatching. And I see that Therese has mentioned, what about limnaeus snails? Yes, thank you. That's a good suggestion. We could add aquatic snails to this discussion. We didn't discuss them on the day actually in November, but that's a good idea. And there's another question. What about carbon nanomaterials? Can we functionalize them to see them? Most of these problems around measurement methods and detection for the carbon-based nanomaterials, and Rachel's going to talk about detection in the in one of the next slideshows. But essentially, it's the absence of a routine detection method that's limiting our ability to do the bioaccumulation measurements at the moment for the carbon-based materials. We're looking for a carbon nanomaterial in a big carbon background in the specimen. Can I provide a reference for the digestibility assay? Yes, if you look at my review paper from 2018, there's some references in there that you can look at on that method.
Okay, perfect. Thank you ever so much then, Richard. We'll be providing the slides to all the delegates afterwards as well, so any references that Richard has made, you obviously will be able to get from the slides. So we now move on to the next speaker, which will be Susan Dekkers from RIVM, who's talking on the scientific basis for OECD test guidelines on in vivo toxicokinetic study. And over to you, Susan.
Thank you. So this presentation will present a little bit of the highlights and the updates based on the feedback we received in the NanoHarmony workshop and in the OECD joint expert group on the toxicokinetics, and obtain any additional feedback and answer any questions if there are any. Next slide, please. So I will give a very short introduction on the approach we used to draft a gap analysis on what's there so far, and then present a little bit of the feedback we already received. And then in the end, I'll answer some questions and receive hopefully any additional feedback. Next slide, please. So for the draft gap analysis, we used an approach to see if there was sufficient data to roughly estimate the exposure dose and duration of exposure, the post-exposure period, and also the number of time points to determine tissue kinetics, specifically in secondary organs within the in vivo toxicokinetic study. So really all minimum requirements for the study design. For this, we use kinetic modeling in combination, of course, with in vivo data on oral and inhalation toxicokinetic studies. And we're aiming at using a couple of model substances, two of which are quite slowly dissolving within the body. That's cerium dioxide and titanium dioxide, nanomaterials, and also a more moderately quickly dissolving nanoparticle, silicon dioxide. And for these materials, there's the dissolution rate in relevant physiological media is investigated, but that's another project or another task within NanoHarmony that will also get attention there. So this is what we used as an approach. Next slide. Oh no, maybe I should tell a little bit about the figure I have on the left corner. Well, this is a hypothetical distribution or concentration during the exposure period and after post-exposure via inhalation of the concentration of nanomaterials in the liver. So you see it starts to accumulate, and then after exposure it will take a while, and then it will start building down or getting eliminated from the liver again. But this last process is quite slowly. Next slide, please. So we got some feedback, and well, there's a lot of feedback and a lot of suggestions were there, and we sort of try to summarize them and put them into different categories. And then the first category is those that we will actually be taken into account and address while developing the scientific basic for the OECD test guideline. Something that came up was this suggestion to really separate inhalation from oral exposure, because they have different features and different requirements. So we will take that into account, definitely. And well, as I just told, we try to distinguish the very slowly and the moderately quickly and even the very quickly dissolving nanoparticles. But for this, it needs to be very clear how we define it, what the cutoff values are, and also how to measure that. So the last bit is already a separate project, but well, in our approach, we need to be clear for this. Well, if you want to determine the exposure regime and the post-exposure period that you are needed to really follow the toxicokinetics in secondary organs, it's not only the dissolution rate of the nanomaterial that is important, but also analytics. So there we touch again to the project that will be presented about the detection of the materials within biological samples. So it really depends on the analytical measurements and the limit of detection. If you use, for example, ICP-MS and determine the elemental concentration, it's also important to know the background. For example, if you have elements in the diet, you will have you may have quite high background concentrations already in several tissues. And also taking into account that the administration mode is very important, whether it's via a bolus or more chronic exposure. Then definitely the particle size is important, and also the agglomerated particle size, because this really determines how much is taken up, but also the processes of elimination, for example, via urine, this particle size is very important, and we can use this in determining the specific design. Of course, when you look into doses that you need, it's also important to know where the toxicity will you expect to occur, at which dose. So this is also something that needs to be addressed. Next slide, please. Some other very important common suggestions with we will address is animal welfare, of course. There were some suggestions in the gap analysis on key organs and tissues to be analyzed. And it was also really suggested and commented on. Of course, it depends on the purpose of your kinetic study, which organs you may additionally include. For example, reproductive organs you may add, and depending on the exposure route, it might be interesting to include the olfactory bulb or Peyer's patches specifically. Also, if you know any expected toxicity of any of your components of your nanoparticle in specific organs, this will also give you the opportunity to add these specifically to your study. Then, of course, something that needs to be taken into account is the number of animals needed for per experimental group to have enough power in your analysis. Next slide, please. Some other things that we need to consider and may need some more in-depth research is the feasibility of including some specific study requirements with respect to the mass balance. Well, from existing studies, we know it's quite difficult for certain, when you use certain analytical techniques to have a high mass balance and to discover, to recover, well, over 90 or 95% of the dose administered with nanomaterials. Also the feasibility of including the urine and fecal excretion, to look into blood kinetics. A lot of particles are really quickly taken up from the blood into macrophages. So we need to see if this is feasible. Transformation of nanoparticles, of course, it's not really metabolism. Usually in nanoparticles, you have more kind of transformation. Sometimes they dissolve completely, but form secondary particles. So this is also something we need to be aware of. And also how to handle coated and surface modified nanomaterials. Next slide, please. Something that came up was the influence of the retention of particles within the delivery system. So for example, the tubes you use when you use gavage. And it's very important to see if this is different from normal substances, and because nanomaterials tend to stick to certain plastics, for example, more easily. The volume of oral gavage, this might really influence the barrier integrity if you use a large volume. Even the volumes that are now, I think it's the maximum that is now in the toxicity studies, might already have some influence on the barrier integrity. So this needs to be taken into account. Also, there was a suggestion to also use all the data we have on IV. We have focused in the gap analysis on oral and inhalation data, toxicokinetic data of nanomaterials, but we can also learn a lot from IV data. And it would be really nice to know the exact dose at the surface where the material can be absorbed. And next slide, please. Well, then there were some other suggestions and comments that we have now put under lower priority. Of course, this might change during the project. That goes for all the categorization of all the comments. But for now, there was a suggestion to broaden the applicability, for example, to larger scale nanomaterials, but also to other type of nanomaterials. Well, right now, carbon-based was also a problem here. Because of the detection and analytical problems, but maybe also next generation materials. Well, we'll first focus on the materials, the particles and the nanoscale particles, and then later on see if we can broaden the applicability. It would be nice, but it doesn't have the first priority. Then our model substances that we suggested were only related to the poorly dissolvable materials and the moderately one, and not to the quickly ones. For example, zinc oxide and silver were put forward that these could also be looked into. There's some data on that. And then, yeah, it would be very nice to know exactly the localization of the particles within tissues and within cells. Nowadays, there's a lot of different techniques that we can use. They're not available for a lot of people because it's usually high tech, but it is nice to use this knowledge if we have that. Also to look into sensitive populations was also a suggestion. Next slide, please. And then there were some remarks that we think that might be or need to be addressed elsewhere for sure. There is, of course, important to know the relationship to the other OECD test guidelines and guidance documents. Most importantly, the toxicity studies 412 and 413 have been updated to also include particles, poorly soluble particles. And of course, we are aware of that, and there needs to be a reference to them and also describe the relation to that. And the same holds for the guidance documents on inhalation and on the histopathology of toxicity studies via inhalation. And then, of course, the test guidelines and guidance documents that are now at the moment under development, for example, the one on dissolution or the one on the determination of nanoparticles within biological samples. Also, the use of in vitro data. There's also a project there now specifically on digestive or an oral exposure. And of course, again, the analytical methods. Something that also comes up quite often is the relevance of in vivo toxicokinetic data in rats for the human health risk assessment. This is something that is a very important issue, but it's not really, shouldn't be addressed in the test guideline itself. It's something that is really much broader and needs to be addressed elsewhere. Next slide, please. That's it. So that's what came out, very briefly summarized. I'm now starting to look at the chat, and I already saw that it's filling up. So I'll try to answer some of the questions and look into the remarks. Just trying to see where it begins.
The first one, Susan, is from Jacques Orion.
Right, thank you.
Secondary generated materials. Do you also plan to update the general OECD test guidelines on toxicokinetics to search also for them for non-nanoforms?
So these are two questions in one, I think. Secondary generated materials, I assume that will be, for example, well, if something dissolves and it forms secondary particles. Well, this is something that we wouldn't give high priority to at the moment, but it is something we need to consider. I don't know if we really need to specify this and can actually make specific recommendations within the test guideline for nanomaterials. We are definitely not planning to update the general test guideline on toxicokinetic. We decided on developing a new one for nanoforms specifically because it is a very different behavior, and these studies need some different emphasis and a different setup of your study design with respect to or in comparison to the toxicokinetics of the soluble molecular chemical substances. And then another need which could or should be addressed elsewhere, maybe the bridge between the two future. Yes, I forgot to mention that is something that came up. Especially if you have substances that are both nanoform and non-nanoforms. Of course, this is something that really needs to be addressed, but it needs to be addressed outside the test guideline, more in a guidance document. But I would agree on that. Now I see a chat underneath. The priority is to update the existing TG or to, oh yeah, I already answered that, I think. We will develop a new test guideline specifically for nanomaterials. I think if that's the questions that I see on the screen. Thank you for that.
I indeed think that's everything, Susan, but I also know you have one more slide, so I shall.
Oh, yeah, thank you for that. Please continue. It's just a short slide to tell the next steps, but I first wanted to open the floor for discussion. So the next is of course to update the gap analysis, to gather any additional data. We are having some studies coming in from other projects as well, to put it all together, to model and to interpret all the data, and then finally to deliver the scientific basis for the study requirements to the OECD project. And well, this is a very quick presentation. If you come up with anything, please put them on the email and email them to my colleague Ilse Goossens. I think that's it for now. Thank you very much for your attention.
Thank you indeed, Susan. And so the next speaker will be Rachel Smith from Public Health England on determination of concentrations of engineered nanomaterials in biological samples using spICP-MS. So Rachel, the floor is yours.
Oh, thank you, Sean. Could I have the next slide, please? Right, so the objectives today are really to give you a taster of the outcomes of the workshop, the sessions that we held on the determination of concentrations of engineered nanomaterials in biological samples using single particle ICP-MS, and also to describe the next stages of the work. And really, we're hoping this gives a further opportunity for engagement with stakeholders. We've been very fortunate. We've had a lot of interest so far, but it's always good to get some further input as we go along. So really what I'm going to be covering today is a bit of background to the OECD project and NanoHarmony activities in support of it, just for those who aren't aware of the project yet. Some of the main points from the workshop sessions, a little bit about the way forward, and hopefully we'll have time if anybody has any questions as well. Next slide, please, Sean. Thank you. So the background really, well, information on the presence and concentration of nanoparticles within biological samples can be important in a range of circumstances when you're trying to interpret the sort of toxicological or ecotoxicological significance of exposures. So for example, if you're doing a toxicokinetic study and with a metal nanomaterial and you find that metal in the liver, say, it is important in any interpretation to understand whether any toxicity being seen is seen as a result of maybe just the metal ions, or is a consequence of the toxicity of the nanoparticles themselves. So we proposed but there's currently very limited guidance on appropriate approaches to use to do this. So we proposed a project to develop a new guidance document on the determination of concentrations of nanoparticles in biological samples to support ecotox and toxicity studies. There are various stages to the proposed project, which form around data collection, analysis, interpretation, some generation of new data to fill data gaps, ultimately leading to the production of a guidance, an OECD guidance document. From our initial looking at the available techniques, single particle ICP-MS, particularly for metallic nanomaterials, is one of the techniques that is the most promising. So we've got to focus on that, but we're not looking at that exclusively. As Thomas said, the purpose really of NanoHarmony is to work alongside, to speed OECD projects, to support and accelerate their development, and to fund data collection, experimental studies and workshops, such as those we had in November to assist with this. And we're fortunate in that that our project is one of the ones that's been supported through NanoHarmony as part of task 1.4. So could I have the next slide, please? So the workshop session objectives. So the objectives are really to identify additional data and also to try and consider priority areas to focus on, with the overall sort of objective of how do we develop single particle ICP-MS as a robust measurement approach for a range of different nanomaterials and all sorts of different biological matrices. We were very fortunate in the involvement. We had over 25 experts from 9 EU countries and very pleasingly from much further afield, and with a range of expertise, which again, we feel this helped enormously in developing the plans going forward. So we split it into 2 sessions really. Session A was on extraction protocols, and this is really how do you take your biological sample, which has some nanoparticles in it, and convert it into just a sort of simple suspension of the nanoparticles that you can put into the mass spec system. So the focus for that was looking at existing data. Have we missed anything? Trying to make sure we were making sure we've found all the relevant references. What are the data gaps? Are there key materials or key biological matrices that haven't been considered? And also, given that there are a range of techniques out there being used, is it possible to make recommendations on the most appropriate protocol? Or are we going to remain with a sort of range of available different techniques? And the second section was focused really on measurement and validation. This is really all about how we assure the sort of quality of any measurement and reliability of any results. So especially for things like single particle ICP-MS, in the absence of a certified reference material, what do you do to ensure that you do have these confidence in the results? So they were the 2 different sessions. So could I have the next slide, please? So for session A, we had undertaken quite a detailed literature review of different techniques for extracting the nanoparticles from these different biological samples. And so we presented the range of different techniques and had a discussion about some of the important issues surrounding them really. And the main sort of different separation were into enzyme extraction and alkali extraction techniques. But as you will see from this slide, there was a range of different aspects to the protocol that were important for considering the resulting analysis. So could I have the next slide, please? So this doesn't capture all of the points made, but it is some of the issues that were raised. So there was questions around sample storage procedures. So even before you've started the analysis, what are the correct way to go? About pre-extraction, using flow fractionation techniques beforehand, would they be useful? Also things like sonication protocols, could these affect the ultimate results? Key issues like detection limits, and points that need to be addressed, like does the extraction protocol create new particles? How can you ensure it doesn't do that? Or does the extraction protocol affect the particle size distribution, which might be an important output as well? And also factors like how do you make sure that your digestion is complete? You don't want to have too much debris left in the sort of chemical analysis. And also factors like validation against alternative methods. So we had a very useful discussion, and we also had a range of projects mentioned to us with additional data that we've followed up with quite a few people since the meeting. So that would be a useful additional information for us to use in this sort of data collection stage. So can I have the next slide, please, Sean? Thank you. So this really shows one of the other slides that we presented at the workshop, which is really summarizing what there is out there in the literature in terms of biological matrices that have been considered and the nanoparticles that have been used. And we had some discussion about, are there missing biological matrices? And there were suggestions about biofluids, muscle, skin, maybe bone might be key for some bioaccumulation of certain nanomaterials. And then some more suggestions of different nanoparticles that perhaps we could consider for doing some future experimental studies on. Next slide, please. So for session B on the validation, we focused this around a few questions. So the first one was, in the absence of a certified reference material, is the spike recovery approach the most useful to determine sort of procedural recovery? Are there other approaches? And I think very pleasingly, I think that the general approach is yes, despite recovery, but you also need to consider potentially other approaches. So looking at mass balance, and there's also other needs around comparing with other techniques, testing particle stability beforehand. So a lot of additional technical steps that are needed in addition to just a spike recovery to assure the sort of robustness of your measurements. And also, again, similarly to our session A, an indication of all the different problems and issues that need to be addressed, such as the fact that protocol and consumables may affect recovery. Spike recovery may depend on the type and mass of the spike used. How to demonstrate that your spike doesn't produce, or if it does, how to account for the fact it might promote formation of particles. And also the fact that some studies have shown that biologically incorporated nanoparticles typically are harder to extract than spike nanoparticles. So a number of key issues. Another question we posed was, what are the appropriate criteria for acceptance of analysis? And I think the general, we didn't probe this perhaps as far as we could. And I think the general feeling was it depends very much on your purpose. If your purpose is to show that there are nanoparticles in a sample, then that is very different from a case where you need to actually quantify it to a particular level. So I think that's an area we'll be revisiting. And we had a final very fruitful discussion on options for making reference materials. So perhaps growing cells with nanoparticles, using soft gelatin capsules, and also maybe approaches we could consider in terms of where funding might be available, and how we'd have to engage with a certified reference material producer that was appropriately accredited. So that was a very useful discussion on validation approaches, which we'll be using to advance our sort of plans for experimental work, and also for factors that we need to include in our guidance document. So that's a bit of a rush through, but can I have the next slide, please, Sean? So I just wanted to briefly mention that the next steps. So we're really still in the sort of data collection and gap analysis stage. So the green ovals are really where we are at the moment. So we've sort of started our literature review related to single particle ICP-MS, and we've had our expert workshop, which has fed into the literature review and contributed to the data collection and gap analysis document, and also provided some data from ongoing projects, national and EU projects that haven't yet been published, which is very important. So for the beginning of next year, really, we're going to be focusing more on the sort of, I think that's, to me, it looks orange, on the orange sort of phases. So we need to do a more thorough job of making sure that we've identified all the data out there that hasn't been published, but in relevant EU projects and other international projects. So if anybody is aware of that, we'd be very grateful for information on relevant projects. But also, more importantly, and I think I touched on this earlier, is to look at other measurement techniques. These are particularly, I think, as Susan and Richard have already mentioned, that there are always issues with things like carbon nanotubes, the difficulty of measuring those carbonaceous materials. So that'll be a sort of phase in the new year to look at that. And so we're hoping to complete our data collection and data analysis phase in the first sort of half of next year. And that will then feed into some experimental studies that we're planning to undertake on single particle ICP-MS. We also have some funding to look at enhanced dark field microscopy, with a particular focus possibly in the future on carbon nanotubes. And ultimately, when we have the results of those, the results from the experimental studies and the data collection and gap analysis will feed into a scientific report, which will then provide a sort of backbone from which we can draft the guidance document on the determination of concentrations on nanoparticles in biological samples in consultation with the OECD expert group. Although clearly there's a sort of demarcation between the NanoHarmony aspect and the OECD aspect, there are very strong links between them. And the other thing I just wanted to mention here is that you'll notice on the right hand side that there are another series of expert workshops planned for late next year. The plans for these have not been finalized in terms of their content, but I think one of the things that we may consider looking at for that is different techniques. Perhaps we might even focus on techniques for carbonaceous materials, but that's I'm just trying to whet your appetite for another opportunity to input and join in this project. So I think that's about it from me. Sean, I think perhaps I've got a final.
You've got one more slide.
Have I? Oh, sorry. No, this is just yeah. I don't think I really want to cover this. This is just the sort of time scale of we're currently where the orange arrow is in terms of the NanoHarmony project, and where we just submitted our OECD project to WNT, and as we moved on down onto the right, hopefully by the we're talking about January 2023. Oh, sorry. Month 30, September 2022, we will have our sort of scientific report ready to start drafting our guidance document. But if anybody wants any more information on the OECD project, do ask. So I think the next one is the last one, please, Sean.
It is right. Thank you, Rachel. There are some questions in the chat indeed. If you have 2 minutes, if you start from Werner Cole's question, and the previous ones have been answered.
Is it a standard technique? Well, we did have involvement from some small and large companies who are using this. I think probably from a routine perspective, they seem to be doing it more for product analysis. I think sometimes to feed into the answering questions about the definition, the EU definition, but people are using it at that sort of level. Then I've got Jutta. Oh. No, I don't understand that one. Pollinators and bees. I think I'm skipping over that one.
Jutta's answering something further
on
right.
Up. That's
so I think it's the question that starts to measure biological tissue residue.
Right. Yeah, that is definitely one of the things. Yes, sorry, I probably should read this. To measure biological tissue residue, the standard method in lung burden for substances like brake dust, asbestos fibers is to ash the tissue, then SEM the remaining material. We are going to be looking at microscopy techniques. We don't have any funding to look at them experimentally, but we will be looking at the literature out there and trying to come to some conclusions. And looking at what's available for things like asbestos, although they clearly are much larger fibers, is one of the key areas we're going to be investigating. Material specific. So a question from Kai Paul. Acceptance criteria is key. Yes, I think we agree with that, especially when quantifying. Do we know when this will be looked at? I think this is going to be something we're going to return to this year, and maybe one of the things we will be discussing, covering at the next sort of workshops. And do we think it might be material specific? I'm not sure. I think it's more likely to be circumstance than material specific, and it may even be more likely to be sort of biological sample specific potentially. But interesting question. Thank you for that. How good is the limit of detection, limit of quantification? Is the morphology kept intact? Well, the morphology is kept intact. The limit of detection and limit of quantification depend quite a lot on the material type. This is one thing that we didn't cover in detail in the workshop, although we have been looking at as part of the literature review. One of the issues is that there are sort of theoretical models of what the limits are, but we want to look a bit more about the literature. But the actual development of the technology is making these levels go down at the moment. So it's difficult to get a handle on, but that is definitely something we need to consider, because for some things like gold, they're very low, and maybe the size limit might be sort of 10 nanomaterials, but for others it's much larger, which clearly has an implication for when you're planning toxicokinetic or any toxicity study using these materials, if you want to be able to find them afterwards.
Okay, thank you ever so much, Rachel. If people have any further questions, obviously keep asking in the chat. Where the speakers aren't able to answer them directly verbally, if we're running out of time at the end of a session, I'll ask the speakers to make sure that they go into the chat and type an answer into those. So the next speaker that we have is Isabella, who will be talking on data requirements in test guideline, data gaps identification related to intestinal fate of ingested nanomaterials. So over to you, Isabella.
Thank you, Sean. And first of all, I would like to apologize because this workstation has no camera. Then I am only present in voice this afternoon, but okay, I think that will be okay for all of you. Again, good afternoon to all, and I'm speaking about the output of the expert workshop and that was held in the first days of November, and that is part of the mission of NanoHarmony and on the mission of our task that is focused on scientific basis for a new guidance document, OECD guidance document on integrated in vitro approach for intestinal fate of oral ingested nanomaterials. The next slide, please. Okay. The main aims of this webinar, as already recorded, is to introduce and to describe the most relevant aspects discussed during the expert workshop, and to present the main feedbacks collected in this workshop. Again, it's important for us to collect, to discuss additional feedback from the audience in order to obtain supplementary suggestions. I would like to underline very briefly that our approach is characterized by four different parts or four different aspects, altogether contributing to the definition of the best approach for study the intestinal fate of ingested nanomaterials. Especially in terms of predictivity and reproducibility in order to comply regulatory needs. These four pillars are the acellular part, in vitro cellular part of the model, that is semi-rapid digestion, a advanced cellular in vitro cellular model formed by a co-culture of intestinal cells, the specification and description of the analytical detection, and finally the correlation between in vitro and in vivo data and the study of predictivity of in vitro data in respect to the in vivo situation. Next slide, please. In the last months, activity of the task was focused on performing a critical analysis of the state of the art, and this analysis has been carried out using published scientific literature resources as PubMed or Google Scholar, and it has been focused mainly on metallic nanomaterials, in particular titanium dioxide, silica, and zinc dioxide. This state-of-the-art as was performed according to some criteria and templates that has been previously defined also at the OECD level. In this slide, I reported some of these criteria or key structure that are being used. And as you can see, some keywords are inserted in this research system. Year range of about 10 or 15 years has been covered, and some key parameters has been identified. In particular, physical chemical properties of nanomaterials, some key parameters for the cellular model, the same for cellular model, and particular attention has been posed on dosage, on study on dosage used in these studies. To date, as I already said, this analysis was limited to some materials, but we want to include in the future other nanomaterials, particularly relevant for oral exposure. Anyhow, templates are living documents, so that so they will be continuously updated over the entire project. Next slide, please. Shortly, I would like to present some of the main gaps evidenced in the different areas of our project. For which concern the acellular model, the main gaps evidenced are reported in the first part of the slide, and as you can see, static consecutive setup with complete but simplified juice seems to be the gold standard method to have a clear depict of dissolution nanomaterials. However, more data need to be substances. So far, few data on dissolution using simulated juice, including food, are present in the literature. And finally, no standardized validated data on instrument setup are reported. Although this method, the standard method for preparing simulating juice are widely applied. In the low part of the slide, the gaps evidenced for in vitro model of cell co-culture are reported. In this case, we are evidenced some pitfalls for which concern the co-culture model, in particular for which concern the M cells identification. There is a lack of comparison between mono, B, and 3 co-culture model in respect to nanomaterials effects. And another problem is the use of very high doses that make very difficult to compare in vitro studies with in vivo studies. Next slide, please. Here are reported the main gaps evidenced for the other two pillars, the analytical detection and in vivo in vitro correlation. For which concern the the analytical detection, we observed that a large panel of techniques has been utilized for quantify and characterize nanomaterials, either from a qualitative point of view, that is present or absence, and quantitatively point of view, that is the exposure. These analytical approach are not able to provide number and mass-based results. Some probes have been identified in the sample preparation and the technique used for sample preparation. In particular, these techniques are not able to separate well nanomaterials from ions. And then consequently, these techniques are not suitable to distinguish between ions and nanomaterials, and then can be an under or overestimation about these two different species. From the in vitro in vivo correlation part, some gaps were evidenced for which concern feeding administration. Very frequently, gavage is used instead of feeding exposure. Lack of relevance in respect to the daily intake. Again, also very limited studies are found in the literature for in vivo, in vitro correlation, especially in the same studies, and then it's very difficult to compare them. And also, this is another interesting point raised during the discussion of data gaps. There is a lack of diseased animal models and for study effects of nanomaterials. Next slide, please. Now I present you some of the feedback derived from the raised during the expert meeting. A useful and lively discussion occurs during this meeting, and we are reported some, I collected some of these feedback. Again, we start with the acellular model, and in this case, consecutive protocol for in vitro simulated digestion is considered robust enough and could be considered as gold standard. However, as already said, additional data, especially for its standardization, are still required. No study using dynamic assay were found. This is another interesting point. The reason of this data lack need to be further addressed and investigate, also in the perspective of drafting guidance document. Another point already presented by Susan during her presentation is the dissolution rate. The dissolution rate is a cross-cutting point in NanoHarmony project, and then a clear definition and harmonization of the terminology is strongly requested in order to define only in one mode the level of dissolution, for example, slowly, moderate, and moderate quick, and quickly dissolving nanomaterial. That is very important point that has been raised during the discussion, but I know that other speakers face this problem during this webinar. Moving to the cellular model, in this case, the discussion was focused on CACO2 cellular model. Differentiated CACO2 model can be considered as a good starting point for in vitro model of intestinal barrier, since it has been extensively used and characterized, and it is quite reproducible. However, the cells net need to be used under a very well-defined condition, and some bias are inherent in the model, for example, the tumoral origin of these cells. This point has been suggested from experts. This point has to be clearly reported in the guidance document. The bicultural model of CACO2 and HT29 cells, due to the presence of mucus, could be a good model for nanomaterials uptake and translocation. To date, the data of nanomaterials uptake and translocation present in the literature show a good reproducibility. Then we think that this model is really a good start point for nanomaterial studies. Another very starting point that has been raised during the meeting is that in any way, the choice of the model depends, is strictly linked to the specific purposes. For example, some important information may be obtained only with the addition of lymphocytic or macrophagic cells. That is the use of so-called inflamed intestinal model, inflamed mucosa, and many papers are present on this model, and it absolutely represents a very good, interesting in vitro models, and absolutely it will be considered in our guidance document. From the perspective for the future, for both these parts, we think to improve further the state-of-the-art analysis, but above all, the definition of the best experimental condition for both these models, acellular and cellular. Next slide, please.
Isabel, can I ask you to be very quick on this last slide?
Yes, very quickly.
Thank
because
you.
this is the last slide, okay? These are the feedback from the other two pillars. You can read directly in the slide, and I don't comment them, and only just flash about the discussion. Really, it's important to use for analytical studies more than more than one analytic approach. This is important because, especially because some technique may become obsolete, and this system can partially overcome this aspect. For which concerns the in vitro, in vivo correlation, again, the link between experimental doses and daily intake is crucial. Some experts observed that gastrointestinal conditions are very different from experimental animals to human. Then the importance to modulate and to study the results in this perspective and consider this aspect in the guidance document. And also the use of standard reference nanomaterials as reference material, use a reference material with a good in vitro in vivo correlation as reference material suggested in the guidance document. Also for these two parts, the future improvement will be the setup of best panel of analytical techniques for nanomaterial detection in the different phases of the digestion process, and possibly study the correlation between nanomaterials accumulation and toxic effects for some selected nanomaterials. Also, the aspect of interaction between nanomaterials and macrobiota as important has been raised during the discussion. Last slide, please. I closed my presentation, and thanks to all the experts who worked together in the expert meeting. And please send me or use the chat for additional question, clarification, and suggestion. Many thanks for your attention.
Thank you ever so much, Isabella. And indeed, if people have questions, then again, feel free to put them in the chat, and we'll make sure that the speakers do address them. So I'll move rapidly on to Maria, who's going to introduce our next presentation on addressing gaps for conducting OECD test guidelines 201, 02 and 03 assays with engineered nanomaterials. Over to you, Maria.
Well, I will present this next slide. What we are developing under the NanoHarmony project in task 1.9, which deals with the scientific basis for the development of technical recommendations for conducting assays with engineered nanomaterials according to the OECD test guideline 201, the freshwater algae and cyanobacteria growth inhibition test, 202, that is the Daphnia acute immobilization test, and 203, the fish acute toxicity test. In this task, we participate 3 partners, the National Institute of Agriculture and Food Research and Technology, Madrid, Spain, INIA, INERIS, which is the French National Institute for Industrial Environment and Risk in France, and the University of Aveiro in Portugal. And our aim is to generate sufficient information and scientific evidence to support the development of a guidance or different guidance to be included as annexes to the guidance document 317 that has been recently published. It is the guidance document on aquatic and sediment toxicological testing of nanomaterials. Next slide, please. Well, previously to the workshop, we have generated a questionnaire that we have distributed to 31 experts that we invited to the workshop, the November workshop, in order to try to identify which are the difficulties and which are the solutions on how to conduct this test guideline, these 3 test guidelines. In relation with which will be the adaptation of the test guideline 201, here are the questions that we report in this questionnaire. In blue are those that are common for the other 2 test guidelines. So the first question is deals with the modification of the test medium described in the test guideline or in the preparation of the suspension, if there is a need to change it, how to adapt, if there is a need to adapt the test vessels or the digestion systems, also the lighting system, which are the best methods to determine the algal biomass or the concentration, which technique is the most appropriate. If there is a need to use extra controls besides the ones that are required in the test guideline, in order to determine if there are any interaction of nanomaterials with algae or assess the interference in the biomass measurements, and which is the best parameter to express the exposure concentration, the mass concentration, surface area, particle number, or particle distribution. Next slide. Related to the Daphnia immobilization test, we have same questions about the idoneity of the test medium described in test guideline 202, or the preparation of suspensions, the test vessels, if there is a need to modify the overall exposure system, use of extra controls, and how to express the concentration. Next slide. For the fish acute toxicity test, we ask for specific conditions for the aqueous media related to the hardness, pH, organic substance orders to obtain stable suspensions, which is the most appropriate material in the aquarium, which are the agitation systems that we can use, on the appropriateness of the limit test when we deal with non-stable suspensions, and how the experts considers the stability and transformation of the nanomaterials within the 96-hour exposure. Also, which were the criteria to renew the water in static or semi-static conditions within the 96-hour exposure. If we use extra controls, and which is the best exposure concentration expression. The next slide. So this questionnaire has been, we have some feedback from the questionnaire, and we have been discussing this during the workshop. And the main outcomes were general for the 3 test guideline relate to the procedures for preparing the test dispersion and the series of concentrations, about the stability of the dispersion and how to express the results. And we have some specific points addressed for test guideline 201. And the next slide, please. In relation with the procedures for preparing the test dispersions and the series of concentrations, we were discussing on which were the best test media or water to use in order to enhance the stability of the test suspension that's enabling a more reproducible result and exposure. And the conclusion from a regulatory point of view were that as much as possible, we have to use the existing and the recommended media in the test guidelines to enable the comparison between the already existing data with the new data, and also to enable the process for read-across or Cursor modeling. Next slide, please. Relate to the how to prepare the dispersions and the series of concentrations. We should focus on these two recent test guidelines that were published in July 2020. The one is the 317, which is the guidance document on the aquatic and sediment toxicological testing, and the 318, which is the guidance document for the testing of dissolution and dispersion stability of nanomaterials. Some specific recommendations were to remove EFTA. This is something that is already advised for metal ecotoxicity testing. And when we use the usual media, but we need to change something to be able to have stable suspensions, we should start by changing the pH, then the hardness, and finally the content on organic matter. The addition of organic matter is normally should be normally avoided, and only in a specific case we can add them. For this, in the guidance document 317, there are some advice in its section 6. The next slide. Also, dealing with how to characterize the dispersion and suspension in order to see how stable they are, and if there are other forms like ions, particles, the aggregate solutes. It was recognized that DLS is not the best procedure because not all the particles are spheres, and the measurements is a light method that is influenced by the particle size distribution. Also, the DLS is not very appropriate when you measure you characterize your nanoparticle in the presence of organism, because the method might not be able to discriminate between the particle and the molecules or particles excreted by the organism, and it was advised to add control without organism as a good principle to characterize the size distribution during the exposure period. Also, not only to use the DLS, but other different methodologies should be envisaged to have accurate exposure characterization. And also there is a need to monitorize the exposure concentration at the start, during, and at the end of the test to be able to make a balance, a mass balance, to see what was internalized or attached to the test organism or to the device, and what was left in the suspension. The next slide. Other recommendations were to avoid as much as possible the use of surfactant tanks to stabilize the suspensions, even if we use the surfactant tank as a control, because it is known that they can potentiate the toxic effect or also favorize the release of ions or disturb the exposure conditions. The vessel should be selected to limit absorption. Relate to the flow-through systems that could seem to be the best ways to expose the organism to have stable suspensions. It was discussed that also these systems can bring several problems like distributing inequally the nanomaterial in the aquaria or to be absorbed in the tubes. And in relation with the limit test, when we use the limit test at the 100 milligram per liter concentration, we should be cautious with this and let it depend, and this concentration should depend on the range of concentrations where you can get stability and low aggregation. And the next slide. In relation with the expression of the results, it was agreed that the mean concentration is essential for comparison with other data, but that other parameters that like the particle number or the surface area may add value depending on the nanomaterial specificity. And another thing that was discussed is that it is advisable to report when you know if the effect is due to a biological effect or to a mechanical or physical effect. This is something that could help to know the mechanism of toxication, but always knowing that that is something that is not mandatory for from a regulatory point of view. The next slide. And finally, in relation with the OECD 201, there was some discussion about the exposure system and the algal biomass estimation. In relation with the exposure system, there were some concerns regarding the use of microscales due to the small volume, the limit hydrodynamic, and the possibility of sedimentation. Also, there is a need to be more prescriptive to the steering parameters, and it was recognized that maybe the smaller volumes will be helpful to avoid the shading effect. In relation with the need to determine the limitation of the current method to estimate the algal biomass, it is known that the direct biomass measurement is not appropriate and should be avoided, that there are some drawbacks depending on nanomaterials and their ability to form heteroagglomerates if you make a direct cell count. And also there are limitations depending on the nanomaterial test and the concentrations when you make indirect measurement by autofluorescence. It seems that the measurement of the chlorophyll A concentration may be a good alternative to overcome the limitation due to the heteroagglomeration, and it's advisable to make previous studies to see on the interaction of the nanomaterials with the wavelengths of absorption of the method. Also, it was advised that a decision tree to choose the most appropriate methods according to the nanomaterial test may be helpful and should be developed. And yeah, that's all. The final slide, please. I would like to have your question, remark, and suggestions that are very welcome. And these are the contact emails from the three partners of this task. And thank you very much.
Thank you ever so much, Maria. There are a couple of questions in the chat, but if I could ask you to answer them in the chat if possible, please, just because we're running slightly behind time now. And so I'd like to move on to our next presentation. But Teresa, Maria will answer those questions in the chat for you. So then we can move on to Jutta, who's going to be looking at solubility and dissolution rates.
Thank you very much. I would avoid to turn on my video because my internet connection is a bit wobbly. Thank you very much for this possibility to talk about the dissolution, solubility and dissolution rate of nanomaterials in the water and relevant synthetic biological media. Next slide, please. Based on the workshop in November, I give you here a background update and background information about the solubility and dissolution work we are doing. And I would like to start with 3 different setups we have. We have at first, you see that on the left side, the sequential gastrointestinal solubility testing. In the middle, we have the continuous flow system. On the right side, we have the atmosphere temperature pH controlled stirred bed reactor system. So in this project, we have on one side the conventional traditional setup, which is the sequential gastrointestinal testing for the oral uptake on the one side. In the middle, we have the more advanced continuous flow system. In this case, that's for inhalation. And on the right side, we have the atmosphere temperature pH controlled bed reactor system, which is again a static system, but is used for inhalation and short-term setups. So these 3 setups are also based on already existing work. So the sequential gastrointestinal work, which uses artificial saliva, artificial stomach medium, and artificial intestine, is based on the ISO 19738 and uses different pHs. It starts with a pH 6.4, which is mimicking the pH in the saliva. Then we go on to the very acidic pH in the stomach, followed by the more basic pH in the intestine. For the continuous flow system, the dynamic system, simulating the inhalation, that is based on ISO 19057 and uses Gamble's medium Gamble solution at the pH 7.4 and PSF at pH 4.5. You can, in this setup, simulate the pulmonary uptake for a relatively short term, so 1 hour or even less, to a couple of years if it's working very well. So this work has already started in the EU project Patrols, and this setup has already distributed to the Korean laboratory, to do CRIS, that's the metrology laboratory in Korea, and that was very successful already. For the atmosphere temperature pH controlled stirred bed reactor, as I said, that's again a static setup. It uses as well the Gamble's media at pH 7.4 and PSF at pH 4.5. It uses as well the ISO 19057, and this one is set up for the very short-term dissolution, focusing on 24 hours. And again, this setup is also possible to transfer for the gastrointestinal testing, and that has been done during Patrols as well, but also at the NRCVE. And that system has also been transferred successfully to CRIS.
Jutta, you've gone on to mute.
Next slide, please. Sorry. So for these three setups, I would like to give you the current update, how far we are for this sequential gastrointestinal solubility. We have drafted the SOP. We also drafted a guidance document with some guidance and tips related to the SOP, which also focus on specific points you have to be aware of for hopefully a successful outcome. We include sample preparation from previous project and also ionic controls and matrix matched ICP-MS calibration that mainly focuses on cerium, zinc, aluminium, aluminium oxide, titanium, and also silver. And recently it was added a little bit of microplastic, so it's also possible to use in this context, but we have not tested it for carbon-based only materials. We are preparing at the moment for intra-laboratory ring trials and finalizing all the documentation. There is also some additional work planned as an outcome of the gap analysis work, but I will refer to that a little bit later. That involves zinc oxide and titanium oxide. For the continuous flow system, there is a draft SOP ready, which was created by in Petrols and is revised now. We have justified adjustable parameters, predictable influence of fluid volume, flow, and the valid range. There is a publication out there which refers to that. And for the lysosomal simulant media, out of the 5 media identified, 3 are valid, and that work was done by ISTEC and BASF and has been submitted. In general, with this system, more than 100 nanomaterials have been tested, and also benchmark material has been identified. Especially pigments have been tested in this setup as well, and a couple of materials which could, depending on the definition, be identified as advanced materials. For the atmosphere temperature pH controlled steered batch reactor, the validation was done on OECD materials, and this work was done in triplicate and based on aluminium oxide, titanium oxide, zinc oxide, or different zinc oxides, and silicium oxide, cerium oxide, and bentonite. This work is finalized, and the data analysis is in some cases ongoing, so filling the gaps, and the manuscript is in preparation. A proof of concept was done with Petrols materials. 12 identical materials are tested in 2 identical setups using the continuous flow system from BASF and the steered batch control reactor from the NRCWE. Next slide, please. So the potential gaps, what we discussed during the workshop, where what essential measurements should be reported, we find that we need a very comprehensive reporting for these methods to ensure we receive the robust measurements that includes the ion concentration at each sampling point and the evaluation of the fitted half-time and the evaluation as rate either via surface area or shape. We agreed to have a need for benchmark materials, and that's what we already as a follow-up now discussed. We are looking for that, and we have identified zinc oxide and titanium oxide materials for that. That was already suggested in the workshop in November, and this work has now started, and hopefully that will work out as planned. And that also leads us to the next point with harmonized selection or harmonized protocols for all these three setups and the relevant particles for that. We will do that, as I said, with zinc oxide and the titanium oxide. So we agreed on NM101 for that, and as I said, the work is already ongoing. So thank you for that from all the experts. And what we already did, we finalized a template for an overall template for the dissolution and the relevant criteria to report to. This will also follow into a guidance document, which also could be used then for regulators to assess the results that originate from different labs and potential different methods. We are using at the moment control materials and hope to have a contribution there for the overall acceptance. Next slide, please. So I already said we have updated now the gracious template, which was based on the NanoRec style, which was developed by from different parties. For the oral one, it was IIT. For the environmental part, it was the University of Vienna. And we also import the EDA from the NanoMapper to make it as widely accessible and fit for purpose for all different stakeholders. So the discussion for the comprehensive reporting is still ongoing, but based on the input from the expert, in a good shape and in a good way. We also agreed to have always the iron concentration as controls, based from the gracious work included at each sampling points, and include that in the reporting. And there is already a section foreseen for the evaluation of the fitted half-time, and also the evaluation of the solubility on dissolution rate, either based on the surface area or shape. Further points of discussion which are ongoing are reporting of the composition media, the temperature, and the steering, what kind of steering, what steering type, and the intensity of the steering. The consideration of size distribution, agglomeration, aggregation, surface and shape of the particles, and how this influences the evaluation of the rate. That is also under consideration, but there is already a very good background paper published in summer 2020, and we will take that in as a base and in consideration to do that. Next slide, please. So this is my final slide, and these are the planned timelines for the round robin. So hopefully Corona will not impact that too much. So by the end of January, we will distribute our final SOPs and give some clarifications. In February, we will distribute the test materials, and to start then in early May, by March, to have the round robin completed. We, depending on the Corona impact and the lab openings, expect that in June. And I would like to encourage all of you and welcome you to join in this ring trials and help us with this task. So with that, I would like to finish and open for questions.
Thank you ever so much, Jutta. Again, if people have questions, if you could please go to the chat and certainly ask your questions in there, and we'll make sure that they all get answered. To keep us on to time, we'll quickly move on to the next presentation. And Jutta, I can see there's already questions emerging in there, but I welcome Jakob to take it away on identification and quantification of the surface chemistry and coatings of nano and microscale materials, new guidance documents.
Yes. Am I clear? Can you hear me?
We can indeed.
Thank you. Okay, so in this task, we will develop a harmonized standard operation procedure for identification and quantification of the surface chemistry and coatings on nano and microscale materials. It will be based on existing SOPs and BFR with Jutta, who was just presenting, and NRCWE with me. We have done some work until now using qualitative and quantitative methods to characterize a range of engineered nanomaterials. So the quantitative techniques are thermogravity and analysis, mass spectrometry, and time of flight secondary ion mass spectrometry and molding to quantitate the surface coatings. And qualitative techniques has been GC and LC methods with mass spectrometry, Fourier transformed infrared spectroscopy, and tough mass spectrometry analysis. This was for the organic part. For the inorganic part, we've used X-ray, fluorescence, and electron microscopy. So based on these preliminary investigations, we will select a minimum of 5 materials for an inter-laboratory comparison, and provide these along with an optimized SOP for the participant in the interlaboratory comparison. Last time we presented 2 nanomaterials, which I guess you can go to the next slide. We presented 2 nanomaterials which should be in a first round, and based on the experience with these perhaps easier nanomaterials, we should select the other 3. So the participants should then use this structured tiered approach, the decision tree, to approach the problem. And it will start with a screening level, level 1, where the screening is compared to a positive control with the suspected coding material. And if there is an agreement between the finding and the control, the screening is complete, identification is confirmed, and the participant can move to the next level and proceed with quantification if necessary. If there is no correlation or partial correlation, it is necessary to go to a higher analytical power instruments to confirm the identity of the coding, and then in the following proceed with quantification. One of the feedbacks from the workshop in November was to also include information from the supplier, which will also be the case in a real-world setting. So that is also taken into account. So next slide, please. We asked two questions, or actually more, but two questions in the workshop in November to the experts attending, and that was which measurements for surface chemistry, surface functionalization, and surface coding testing would be potential and needed. And the feedback from the workshop was to include the nature of coding, the molecular weight, elements present, as well as functional groups in the coding. And other non-essential but preferable measurements could be the amount and thickness of coding, chemical binding type, for example. And there was also a need for certified reference material to improve the measurements. Next slide, please. Okay. We are also preparing a review paper, and in the review paper, which you will see in a few slides, it was clear from the workshop that there was also a need for a clarification of some terms, including surface and bulk. Bulk material is one example where one way to understand the term is the non-nanomaterials, but it could also refer to the surface coating and not the core, so strict definitions are requested. Other issues were, in addition to provide information from the supplier in the interlaboratory tests, also to make a decision to which extent the intercomparison should be quantitative. There were also inputs of additional analytical methods. One expert suggested NMR for characterization, another suggested loss and ignition. And then there was a request about the test materials which should be supplied in the second round. So in the first round, we suggested to distribute the titanium dioxide coated with dimethicon and also a silver particle coated with PVP. but what should be the additional nanomaterials provided in a second round? So we have different suggestions based on our initial work. Next slide. Yes, and this is just an overview of the timeline. We suspect to distribute a standard operation procedure in March, along with the materials in April. Then we can expect the beginning on the interlaboratory comparison in May and suspected to be finished in October. Next slide. Jutta also presented the outline of the review paper, which should include an introduction along with important definitions, analytical techniques, and authentic case studies and outlook. And based on the consensus standard operation procedure which should be built and the review article, this should support the OECD guidance document for characterization of engineered nanomaterials. Yeah, and this is really the last slide. We already got some volunteers for an interlaboratory comparison, and we also got a feedback for co-authors in the review paper. But we encourage everybody to volunteer for both the interlaboratory comparison and writing the review paper with us. Thank you.
Thank you ever so much, Jakob. And I don't know if there are a number of questions going on in the chat. I think most of them actually are related to probably the previous talk anyway, but obviously have a look in there. But I'd ask us to move on to our next speaker, which is Jakob Nøjgaard, who's going to be talking about ATEX, non-harm, and exposure models.
Yes, hello, thanks, Sean. I'm going to talk about dustiness of manufactured nanomaterials, ATEX, non-harm. So ATEX means atmosphere, explosible atmosphere, so explosion type of powders that could make explosion. HARN means high aspect ratio nanomaterial, non-harm, so it's basically spherical particles, and exposure models. So work was done with INIA and RCW, Bauer, and also the OECD experts. Next slide, please. So why dustiness? Dustiness is a key parameter for risk assessment exposure, especially occupational exposure, and also for accidental hazardous scenarios such dispersion. I'm going to shut off this camera business here up. Okay, I got it back here. Okay, good. So in terms of, important for exposure, important for ATEX studies. So that's why we are pushing in this work 1 TG on determination of dustiness and how dustiness is used for exposure modeling and ATEX safety approaches. This responds to regulatory needs, namely REACH regulations and the ATEX directives. Two projects, Go4Nano and NanoHarmony, help us to give the scientific basis of this project. Nano objects that are treated, there's about 6, SiO2, TiO2, HARNs also, mainly nanotube, multi-wall, flexible, non-flexible, and reactive materials like silicon. Next, please. So what are we trying to do? Basically, if you have a powder, we want to know how much can be emitted in the aerosol. If the particles is basically spherical particles or fibers, and that depends, of course, of the energy or the system that you use. So nano first thing is to characterize the nanopowders, and specifically, what's important is moisture content, the bulk density, granulometry, and so forth. And after that, how you generate this through different techniques, different methods that have different energy that mimic different processes. Rotating drum, small rotating drum, vortex shaker, venturi, fluidizer, continuous drop, and continuous drop method, well, the dust view and the regular one. So those are 7 methods that we are going to try to test. Now, once these you generate this dust, you want to measure the dustiness mass fraction, dustiness number fraction, emission rates, dustiness kinetics, the time also it takes to make about 50% of the total number, the granulometry or the particle size distribution with different modes, and the morphological in case of fibers, namely length, diameter, ratio length to diameter, and so forth. So there's going to be some intra-validation and inter-validations of this measurement. And how do you use this? Of course, you use this for exposure modeling and risk assessment, and for workplaces, and also for ATEX, also to compare. Basically, one case is to compare with OEL, occupational exposure limits, and the other one is also to compare with lower limit of explosion. And that gives you the elements for risk assessment. Next, please. So basically, the 7 methods that we are proposing are shown here. There are already some guidelines, standards that come with it. They are shown here. The first one, rotating drum, is led by TNO. Small rotating drum is led by the NRCWE. Vortex shaker by INRS. Venturi is led by NIOSH. Fluidizer by Bauer. And continuous drop just view by BAM, and continuous drop classical method by TNO. So next. So we have basically three priority techniques, because we have more than 5 participants on these techniques, and that's why we prioritize these techniques. Next. So what was discussed last time? Question was raised first. Do you consider that all methods have a potential to support regulatory information requirements for dustiness testing? Well, the answer was yes, but we need in the text to clearly show how the scenario fits with the method, because different methods have different energy, and different scenario processes require different method of analysis. And also, yes, that these tests can be used for exposure modeling. They also, methods that require very low amount could be used for safety by design approach, and they are preferential. And we also, there was also a question regarding that the method should really mimic the activities. The second question, do you think that this dustiness program will provide enough data to generate knowledge to establish method-specific ranking? So method-specific ranking is methods that are used to rank the dustiness as a low, very low dustiness, low dustiness, moderate, or high dustiness, and those ranking are they are very important for risk analysis. However, people mentioned that actually there could be some limitation, because only 7 methods and 6 material will be used, but they could be very, very useful for completing already the data set that we have. Next, please. Third question, do you consider a method-specific ranking scheme could be used for ATEX risk and exposure assessment? Yes, obviously. the answer. However, this for ATEX, for example, the dustiness level could be used to assess persistence of clouds and propagation of explosion. That's something. And also, what's important also is that the scheme and the method has to be related to the occupational or process activity. That means different method of different energy and have to be in line with the process or the occupational activity. Should the mandatory measurements be harmonized and determined for all methods to the extent possible? Yes, the consensus was that actually the mandatory measurement, the one that I show you, should be harmonized and determined for the method to the extent of our possibilities. That means with the number of institutes that collaborates and the amount of energy we can put in terms of time and money. Next, please. In terms of aspect ratio, that means the fibers. What is the most important measurement regarding iron dustiness? Obviously, fiber number concentration. That's something that and EM, electronic microscopy analysis, and that techniques to distinguish fibers from other particles. That was the response of these questions. And next question is, what is your viewpoint towards aerosol instrumentation to determine measurements for iron dustiness testing? Basically, iron dustiness testing is through electron microscopy, this major technique. LP also could be used to to measure the particle size, but also collect samples for EM measurement. And also the particle counters can be used, but they really cannot distinguish between spherical and fibrous particles. The next question, is it viable to formulate an electron microscopy aerosol sample analysis procedure applicable to both SEM and TEM? Yes, the techniques SEM and TEMs in terms of image analysis and counting rules could be the same. However, the procedure of sample preparation could be somehow different. Next slide, please. So in terms of ATEX, there was a consensus that actually within these different techniques, we should have a caveat saying that we should pay attention to ATEX risk when using this method, especially when you have combustible and reactive materials you want to test in terms of dustiness. And the next also a remark is that the use of dustiness for reactive materials could be important for determining the ATEX area, and the area, a safe area in which the people can work without any fear of explosion. So that is important. Next, please. In terms of iron, so to summarize how the dustiness could be assessed, of course, through morphological characterization, EM measurement, counting rules, classification parameters. We need to pay attention to extrapolation of results of these techniques. And also there is a consensus on the importance of image software and harmonized counting rules. Just wanted to mention that actually next year we are going to submit a call for inter-laboratory comparisons of fibers or nanomaterials iron, and we're going to start that in the beginning of next year. So we'll probably be you'll probably have this call sent to you, and we'll see if you're interested in participating and collaborating with us, let us know. Okay. Next, please. In terms of how you use the data, dustiness data for modeling, there is there is work that is presently done here. Here you have a formula showing you the SC, the source term, in terms of DI, which is the dustiness index, H, an energy factor of different method, DMDT, that's a rate of use of materials, LC is safety control or the control of these the different control that you can use to reduce the source terms. So these techniques are still under work. Now there's some work that is being done in comparing the data from a small rotating drum and the continuous drop. It's basically try to from these two techniques that different energy involved, different H involved, and try to have an harmonized way of summarizing basically the dustiness index measurement, so that we can from the source term that shows here, we can use models to predict the concentration of particles near the operator and far field in a workshop, for example. So near field and far field type of predictive concentrations. So still there are some research needs. This is still on the research level. However, there could be use for the guidance document. The high quality measurement is still needed, and especially harmonized libraries also with descriptors regarding emission sources and dustiness are still needed. Next, please. So to finish up, because the time is running out. Finish up this presentation. We thank all the members of the OECD experts. We propose to finish up our TG draft in April 2022, and the GD submissions in June 2022, April 2023. Yeah, so I'm finished. So thank you all. I could answer your questions if you have some.
Thank you ever so much, Shax, and again, thank you to all of our speakers. I'll move on to the closing session, but we would ask if people could stay until after Klaus finishes the closing session, and we're planning to try and do a photograph of as many people as we can, really, just to sort of celebrate the workshop this afternoon. I'm aware on Zoom they are always difficult to do, but it is nice to see. If anybody has any final questions, then obviously get them into the chat now, but for the time being I'll hand over to Klaus, who's going to give a conclusion from the workshop.
Excellent. Thank you very much, Sean. Thank you all for attending, and I'd like to thank the speakers for some great talks and showing us how they've already taken into account the questions and issues that were raised during the November workshops, and also the ones that came up today, or at least how they plan on implementing those into the future. So each of the NanoHarmony Work Package 1 tasks, as they've all alluded to, and some even with specific dates, will be in direct contact with their expert working groups as they move forward. But as you can see here, we'll also have a workshop in March to follow up. So the 4th NanoHarmony workshop, it'll really be around identifying and solving the barriers for translating the science progress that people make into the regulation and the standards that we all need them to inform. It'll be about addressing which aspects of that work process that you at least saw in Rachel's slides, from one end of a scientific development through to a finished guideline or either test guideline or guidance document, and looking at what are the experiences that people are having with moving for each of those steps. It'll cover the aspects right from the data through to the final commenting round on the eventual OECD test guidelines or guidance documents, and really needs the input and experience from all the stakeholders, be they scientists that have developed standards before, been involved in the ring testing, or from the end users that have been commenting on the documents and found things that could have been addressed easier early on. So the preliminary date is set for the 17th of March next year. So hold the date and follow the NanoHarmony website for any updates on the format or the detailed content. Obviously, if 2021 is anything like 2020, changes may abound as we move through time. But other than that, I think it was a good workshop, and if we're quick, we can even finish on time, given everybody kept reasonably to it. And I'd just like to wish you all a good holiday, and for those that celebrate Christmas, I hope you have a good one and see as much of your family as conditions will allow, which obviously is very different around Europe and the world at the minute. So yeah, before we take the picture, I'd just like from all in NanoHarmony to say, stay safe and thank you for supporting NanoHarmony in 2020. And we look forward to seeing you in 2021, hopefully as we move into the later part of the year, maybe even in person. Thank you.